the mole concept, converting between the number of moles and the number of particles. Have you ever wondered, am I smart enough for chemistry? I heard all about the mole stuff, and it sounds hard. Now, if you could answer the following question, you definitely have enough IQ for chem. So first of all, how many eggs are there in 1 dozen of eggs? Now, just in case you don't have enough life experience to know that it's 12, I'll give you this one. Now, Mary bought 36 eggs. How many dozens of eggs did she buy? Pause here and do the calculation. Yep, it is 3. Now, I hope this IQ test boosts your confidence in chemistry like no other. Brilliant scientific ideas come from life experiences. To understand the concept of mole, we just need to look to our daily life. When we say a pair of socks or shoes or a dozen of eggs and so on. We use the word pair when we mean 2 and a dozen when we mean 12. We also say a decade when we mean 10. These words are counting units. They represent certain quantity that we all agree upon. As chemists, we need to count atoms and molecules so as to measure and work with them. But atoms and molecules are so small, it will exhaust us if we count by 1 atom or 2 atoms, and they're not sheeps, we're not counting them to go to sleep. So we decided to get enough of them together and get them a batch, a counting unit, that is mole. So all chemists come together and decide that we are going to count particles mole by mole. What's the number that we all agree upon? 12 for a dozen, like 10 for a decade? Well, for chemistry, for mole, it's 6.02 times 10 to the power of 23. It is indeed a rather large number, but just like if we say 1 dozen, it means 12, we treat this number the same way to convert in between. For example, 1 mole of water molecule effectively means 6.02 times 10 to the power of 23 number of water molecules. Okay, when we say 2.5 mole of glucose molecule, you know what I mean, right? 2.5 times this number. Sometimes we write mole as a unit. When we do that, we shorten it to MOL. Okay, so we can also work backwards. 4.4 times 10 to the power of 23 water molecules. God knows how they actually count that many of water molecules. Anyways, if we want to count that in mole, we just need to divide by the number that we all agree upon, which is 6.02 times 10 to the power of 23. So the common number that we all agree upon is called the Avogadro's number. In summary, for those who appeals to visual representation, this pyramid represents a relationship. The multiplication of the number of moles and Avogadro's number will give us the actual number of particles. It's like 3 dozens of eggs times 12 equals to the actual number of eggs, which is 36. If we know the actual number of particles and we're aiming for the number of moles, we just need to reverse the formula and make mole the subject. Remember, this formula converts between the number of particles to the number of particles counted in mole, molar mass. So we just talked about how to convert between number of moles and the number of particles. With the unit of mole and Avogadro's constant, we're able to count large number of particles with relatively small numbers. However, it doesn't really show us how to measure them. So here's a scenario. A chemist walks into a juice bar where you happen to be tending to and asks you for 3 moles of water. How would you measure it out? Now, do you ever wonder why Avogadro's constant is 6.02 times 10 to the power of 23? Why not 10,000, 1 million? Wouldn't that be easier? Now, Avogadro's number is the exact number of carbon atoms in 12 grams of pure carbon. What a coincidence. There's no coincidence in this world. There is only the inevitable, and that is science. Okay, so basically, the mass of 1 mole of carbon-12 atom would, in value, be numerically equivalent to its relative isotopic mass. What? Right. That just means that mass of 1 mole of any elements from the periodic table will equal to their relative atomic mass. Now, where do we find relative atomic mass? Here on the table, periodic table. In other words, the value of relative atomic mass on periodic table is how many grams it will be if we take 1 mole of that element. Now, it's hard to count the number of tiny particles, but we can measure the mass of its collective and work backwards to find that amount. Now, the mass in grams of 1 mole of a particular element or compound is called the molar mass. It's given the symbol capital M, and the unit is grams per mole. Molar mass acts like a bridge between the amount of substance and the mass of it. So depending on the substances, terms such as formula mass or molecular mass are used. So they basically mean that the molar mass of 1 unit of formula, which is often used referring to an ionic compound, or the molar mass of 1 molecule in question. Okay. So here's the answer to your opening question. How to measure out 3 moles of water? First of all, you do not count because that's going to take you forever. What do we do is, as chemists and chemist bartender, we take out a periodic table and find out the molar mass of hydrogen and oxygen there on the periodic table. Then we first calculate the molecular mass of water, which means that we add those numbers together. Remember that water molecule has 2 hydrogens, so we have to add the molar mass of hydrogen twice, right? We add them all together, and that means 1 mole of water molecules would actually weigh 18.02 grams, right? So how many moles of water molecules do we need to measure out? Okay, 3. So we multiply the molecular mass of water by 3. That means if we are standing there bartending, we weigh it out 54.606 grams of water. That's 3 moles of water. Okay, so as you can see that we cannot physically count 3 moles of water molecules, but we can in fact weigh out 54.06 grams of water and be certain that it will contain 3 moles of water molecules. In summary, molar mass is denoted the capital M. Mass, the one that we could measure, usually appears in grams, is denoted the lowercase m. And then lowercase n is exclusively reserved for the number of moles in chemistry. So we have our second triangle. Mass of a compound equals to the number of moles times their molar mass. We can also rearrange to make n the subject. All right. Now, in this session, we introduced 2 formulas. The first one, when we have a large number of particles to work with, which is all the time in chemistry, because particles are small, we can use mole as a counting unit. It groups 6.02 times 10 to the power of 23 particles together to form 1 mole. And the molar mass allows us to convert the immeasurable amount of particles to their measurable mass in grams or sometimes in kilograms.